All right. Welcome, everybody, to our second day, July 26th, of our Precision Health Bootcamp. Today, we will be learning about software management with Conda and Singularity in this morning's session. I'd like to begin by acknowledging that the land on which we gather is a traditional, ancestral, and unceded territory of the Musqueam people. And the content presented today is under the copyright of CC BY SA 4.0, which is a share alike license. So you are free to share and adapt this content as long as any adapted content has attribution for us as the generators of this content and also inherits the same share alike license. If you're interested, you can read more there at the bottom. So how to get help for the sessions, just like yesterday, except today we have a fresh link. So you can click on this code share here for July 26th. You can post your morning questions here. If there's any other information, if you feel like you want to sign in, you can sign in just here. And this is something that everyone can edit interactively. So as you type into the code share, our TAs will be able to answer your questions online. I know that yesterday the Zoom chat was also used for answering questions. And if that works for people, I'm also fine with that. And we'll try to take a couple pauses for questions from the online audience as well to enrich the experience. Just a couple relevant links for today. Again, the workshops, you can find more about the workshops, this link here, as well as a separate link here for the software section, which this is the first time we are visiting the software section. So in the Precision Health virtual environment, this software README has some descriptions of how to do some of the things we're going to be doing today. So feel free to use that as an additional resource, for example, getting Conda set up, which is what we're going to start the morning with. So some learning outcomes. At the end of the session, you'll be able to understand the importance of portability and reproducibility in precision health data analysis. You'll be able to create and activate software environments with Conda and use the tools within job scripts and on the command line. You'll also be able to download and interact with Singularity or Docker images for use on Sockeye, both in job scripts and on the command line. A little outline for today. Here's Sherlock getting a little bit older, and here he is on his first road trip. There he is with his buddies. So we're going to start with a little bit of motivation for software environments, self-managed software stacks, as they're called, and reproducibility and portability. Then we'll spend most of the first hour on an introduction to Conda, where you're going to create your own mini Conda 3 deployment. We'll create an environment, and then you'll activate that environment. And then in the next hour, we'll focus on Singularity, where we will pull a container, interact with that container, and then run a tool inside the container. The example there going to be variant calling with the deep variant tool. Just a preface for some of the hands-on content today. Many of you might be beginner users to the command line, and so we will try to give you some of those beginner commands, but if it becomes too much to follow along, we have a lot of content to cover, as you can see. Please feel free to revisit the recording afterwards. All right, so first about some motivation for why we care. So reproducibility in precision health data analysis is really paramount. And in the era of digital medicine, it's been claimed that we have a reproducibility crisis. Now, part of the challenge, an additional challenge on top of the reproducibility issue, is that software in genomics and bioinformatics gets released at a staggering rate. This here is just a list of tools that we'll call copy number variants from DNA sequencing, whether it's exome or genome sequencing. And you can see these all in the past 5 to 10 years, there's already over 50 different tools, some with thousands of citations. Another issue is that many common packages might receive version updates to handle things like bug fixes or software improvements and upgrades. So the question is, how do we wrangle this software to get it into our analysis? So what we need is really three things. One, we need a flexible solution that will work across a variety of environments and computing systems. Two, we need a reproducible way to recreate and share all the tools that we might have used in our analysis. And three, we need a system that will resolve dependencies for various software versions. Now, when it comes to dependencies, most software development relies on toolkits and libraries that other people have built and optimized. Now, many of these can be challenging to install, and one way around that is to use Conda. In 2018, there was a Nature Methods paper that described BioConda, which at the time was a quite popular and growing software package that handles many of the bioinformatics tools that we use every day. And back in 2018, if you were even to look at some of the packages that they house on BioConda, this includes many packages for Bioconductor and R, packages that run on the command line, things like BWA and SAM tools, many different Python packages, and there will always be a soft place in my heart for Perl. You can see that as far as total downloads, this number might look large now, but I can tell you it's at least an order of magnitude larger here in 2022, looking at somewhere on the order of 50 or 60 million downloads of Conda packages. Some of the most popular packages having almost 6 million downloads themselves. So the basics of Conda, we know it's very popular. If you want to learn more about Conda, you can click on this link and it'll take you to this website. Now, many people start with just Conda, but I'm here to tell you, you should only ever use Mini Conda. Mini Conda is a more minimal installer, and it doesn't create a large base environment that's going to automatically be loaded every time you log in. So if you have something like base next to your command line, that means that you probably used the Conda installer as opposed to the Mini Conda installer. So in Mini Conda, in order to fetch Mini Conda, we would just click on this link from the Conda website. And then we can scroll down and we can see the Mini Conda installer. So this Mini Conda installer, we can simply grab it by right-clicking on that link. And we are going to go ahead and get started with just that. So let's go ahead and log in to Sockeye. So we will SSH our username at sockeye.arc.ubc.ca. Oops. Our two-factor authentication. Alrighty. So now that we're logged in, we can go ahead and change to our student space or our workshop directory. Now, if you have not made this student space, for example, if you did not attend yesterday's lesson, then you can run mkdir/p followed by scratch tr precision health 1 workshops student spaces $user. And what this will do is this will make a directory with your CWL. So if I go to this place, oops, I can copy that command and paste it in. You can see this is a place where I now can essentially work, and it's unique to my username. If we take a look at the different student spaces, we can see that there are many people with their own workshop directories who've been following along from yesterday. So once we're in that student space, something should look like Scratch. If we type PWD, should be Scratch TR Precision Health 1, workshop, student spaces, followed by your CWL. We can then run this copy command to get the core Conda directory from project TR Precision Health 1, Precision Health Virtual Environment, workshops, core Conda. And we're just going to copy that to our relative directory since we're already where we want to be. So we can copy this command. It's not a big directory, and then we can change into it. All right. Once you've got that directory copied, we can go ahead and fetch the Mini Conda 3 installer. So while people are fetching that, I'll just show you where I got this link if you're ever wondering. We went to Conda. We went over to Mini Conda. Scrolled down, right-clicked here, copy link. We are installing into Linux, 64-bit is perfect. So that's how we got this link here. So right now on the command line, what we'll do is we'll run wget of that installer bash script. So we type that command, we hit enter. It's going to fetch this small install script from the internet. And when we run wget, you can see we can watch the progress bar. It finished in about 0.6 seconds. So now step 3 is that we're going to run the installer and deploy a new Mini Conda 3 directory. So we're going to run this command with bash, followed by the name of this script, which we just installed right here. -B means that we are just going to agree to the license, which they request. And -P means that we want to install this instead of into our home directory, into our $PWD. Anybody know in the room what $PWD means? Yes, so it's going to be our current working directory, a new directory called Mini Conda 3. So we can go ahead and copy that command. And then we can hit enter. Now, what Conda is going to do is it's going to set up this Mini Conda 3 directory with all of the things that it needs in order to install tools and solve environment, essentially dependencies for the tools that we keep within a single environment. So we can see it's unpacking its payload. Could take a minute or two if many of us are running this at the same time. Mm-hmm.
Why do you add the dots before the slash previous one? Dots, it says //.
Oh, this.
Yeah.
Yeah, so the question is, what does this // mean? So I could always give the full file path of the file I want to copy, or in this case, the directory I want to copy and the directory where I want it to go. So I could always give that full file path. Now, that command gets really long. Instead, what I do is I first change into the place where I want to be, right? And then I'm copying this file into / just refers to your current working directory. So I could have also put $PWD there. I could have also put the full file path. So I could have put this there, but / just means the current working directory. All right, we can see that it is finished unpacking its payload and it is now extracting. Oh, There it goes. Sometimes it just needs a minute to think. So what Conda is doing is it's getting essentially all the things that it needs to perform our installs. And it's going to put a number of things into the base environment. However, the mini Conda 3 base environment is quite light, meaning it's not going to put too many things in there that might cause conflicts like the regular Conda does. So when your installation is finished, you're going to see something that looks like this, a new mini Conda 3 directory. Now, before we run that source command, since some of you are probably still running this, we can explore a little bit about what's in this mini Conda 3 directory. So some things that you need to pay attention to would be the bin, which is where tools will live if they are installed into the base environment. This directory called envs, which is short for environments, or envs, which is a weird word to say. So envs. And then we also have this etc. directory. Now, usually we don't care about the etc. directory, but if we go into etc. profile.d, this conda.sh is going to be essentially where our conda command lives. So what we do is we first run this source command, and that will get conda into our path. So if I was to type conda right now, it doesn't know what the conda command is. And if I'm to show you what my path looks like, there is no reference to this mini Conda 3 directory that we installed. So instead, what I'm going to do is I'm going to run this source command. So anytime that you want to use this Conda installation, this mini Conda installation, which you should now have here in your own student space, or if you were to deploy this in your own allocation, you need to run a source command on the path to your mini Conda, followed by etc. profile.d conda.sh. And then we will be able to use the conda command. So I can go ahead and copy this source command, which is going to put conda in my path, and I hit enter. Now, if I type conda and help, instead of seeing a conda not found, it's going to show me the different conda toolkits. So there are several different tools within Conda, and then there's also Conda env. Now, just like many of the things that we've been learning so far, we will never cover everything in this workshop. However, I'm going to show you just the things that you'll need to know in order to create and manage your own environments. So now that we all have Conda set up, we'll just take a brief pause. Anybody have problems setting up Conda? All right. So now we're going to create our first environment. So we've already run this source command, but let's say we logged out and then we logged back in. Now we would need to rerun this source command if we wanted to have Conda in our path. So since we've already done step 1 and we have Conda in our path, we can now skip to step 2, and that's to find your tool online. So the tool that we're going to install first is called Tree. So we can go to Google and we can type Conda install Tree. And you're going to want to find, essentially, if your package is in Conda, then it'll have a reference to this anaconda.org. So we click on that. We can see this package has 23,000 total downloads, and you can install it with conda install And the channel here is Conda Forge. Now, Conda channels, you don't have to learn too much about Conda channels, but you have to realize that some tools are not going to be installed into the default Conda software repository. And so we add these different channels in order to access different parts of the entire Conda network. That's all you really need to know about channels. So we can see this Conda install -c Conda Forge tree. So if we were to run this command right now on the command line, it would put this tree package right into our base environment. Now, instead, we're going to create an environment with this package. And we're going to do that from the command line with the conda create command. So we are going to create this environment. Conda create -y just means answer yes if it prompts you for, do you really want to do this? I think we can all agree we want to do this. -n, the environment name. -c, what the channel is. So here we can see -c is going to be Conda Forge. And then however many tools you want to put into this environment. Now, I recommend not putting too many tools into a single environment because then it will take longer for the environment to solve. And there could be different tools that have conflicts with the libraries or the versions of different libraries that they use. So best practice is to limit your environment to one or a few tools maximum. So we can now run this conda create command. We can just copy this. We're going to conda create -y meaning yes, -n tree, -c, the channel is Conda Forge, and we want to install the tool tree. So if I hit that, it's going to think for a minute. And if I had many different packages, it might think for a couple hours. So we don't want to do that. And then once it figures out that to install tree, you really don't need that much, it's going to tell us what the plan is. It's going to make an environment in this location. Now, we know that because we just ran conda create and we just passed the name, it's going to default to the current mini conda that we have activated. And it's going to create a new environment in a new directory called tree. And you can see it needed to download these packages. And then it installed these packages, extracted them, and finished. So now if we type the tree command, you can see just because we created an environment with this tool and we installed it does not mean that the tree command is going to be in our path. So we have to activate that environment that we just created. So we can conda activate tree. And when this happens, you can see now I've got this little environment name in parentheses called tree. Now, the tree tool, you're about to see what it does. If you copy this command, tree is just a tool that prints a nice visualization of the files in a certain directory. So if I copy that tree command, what it's going to do is it's going to give me a nice file hierarchy of this directory, which we were playing with yesterday, showing that there is a subdirectory with files, and in that we've got some data, a subdirectory with problem set, and maybe some of you attempted that. In the main directory is the README, a subdirectory with scripts, and a subdirectory with slides. Now, if we are done with the tool and we don't want tree to work anymore, we can always Conda deactivate. And now if we try to type the tree command, it's no longer found. I'll just also show you if we Conda activate tree again and we echo our path, you can see what's happened is that the tree environment, that its bin directory has been added into our path. So if we're to list out that environment, we can see the only thing in there is tree. Now, if we installed a number of software tools which we might like BWA and SAM tools, they would be in that corresponding bin for whatever environment they live in. We'll just pause for some questions. Are there any questions from Zoom, or is everyone all right? Yep. Yes. Yes. It is. So the question is whether or not within the environment, the names of the environment and the tools inside the environment are case sensitive. So they are. And that's one of the reasons why I kind of like showing here. I name it tree, right? I could name this anything. I could name it Sherlock if I wanted to. But the tool itself has to match the actual tool on, for example, where were we looking at that? It's going to have to match this. So if instead I had typed capital T here, it would not have worked because it would say package not found. In fact, we can go ahead and just, just show you if we were to try and we'll call it deactivate. We already have. So if we were to try and install this, it's going to search for a little bit and then it's going to say, oh, maybe there is something else. There is another tree? Maybe. I don't know why that happened. That's interesting. There you go. You learned something new. Well, it shouldn't have worked, but best practice would be to keep this where this is matching exactly to what you see on the install instructions. Are there any questions from the online audience before we move on? All righty, we'll keep on going. So now we can type some of the other Conda commands. One of my favorites is Conda env list. So if I type Conda env list, it's going to list out all of the different packages or all the different environments that I have installed. Now you'll see I've got several environments installed within the project STSTurvy1 Precision Health Virtual Environment Software Mini Conda 3 directory. That includes some environments we'll use in later sessions like Deep Lab Cut, RNA-seq, an environment we're going to build just now, genome analysis. And then you can also see this is the Conda environment I just installed. It's got a star next to it because that's the Conda that I currently have activated. Now I have multiple Condas, one in project, you see here, one in Scratch, you see here, and you probably have your own that's also in Scratch. Now, even though I have multiple Condas, this is the one that's currently active. But I can activate any one of these environments. So if I wanted to activate this environment, which has the Amazon Web Services command line interface or AWS CLI, I can simply type Conda activate, give it the path to that environment. And now I have the AWS S3 command line. So if any of you are used to using AWS command line interface, this is an environment that has that toolkit. And it does not have a nice help function, as you can see. It doesn't know the option help. That's a classic Amazon problem. So again, this was the environment that we just created. That's our base environment. You can copy and paste and load those environments, which another one to activate. So if we Conda deactivate, because we're not interested in the AWS CLI, instead we might be interested in this fun tool called gget. Now I have gget, and we'll see if that help is any better. Oh, look, it actually has a nice help description. This is a package, actually quite a fun package from the Pactor lab, Lior Pactor's lab, where you can fetch different reference genomes, annotations, and information about your genes of interest using things like ensemble IDs. So again, when we activate these environments, what we're doing is we're adding into our path essentially the directory for that environment, and specifically the bin directory, where things like the executable, like the gget executable, will live in that bin directory. And there it is. Again, if we were to echo out our path, we can see now that we have the gget environment activated, our path includes the bin for that gget environment, which is why we can type gget and get a help message. And again, when we Conda deactivate and we echo our path again, now that first environment is gone. You can see it's no longer in our path, so we no longer have access to the gget command. Yeah.
When I do the environment list, it doesn't show all of the project ones,
Mhm.
but then I'm still able to run the gget one and install, but it still doesn't show up. But how come it's different from?
Yeah. It might be because you've never sourced that environment. That's a good question. So the question is, how come when you run conda and list, you don't see the environments that I created in the project space? So you might be able to run a source on this mini conda, and that might add them. So if you were to source that, etc., profile.d conda.sh. So if you were to run that, then it might add those environments into your list. But that's actually a good question. We'll talk later about that. We'll see if we can figure out why you don't have it. But you should be able to activate that environment. Did it work?
It did work.
It did work?
Doesn't show up.
It does work, but I just don't see it listed.
Yeah. Okay.
I have another question.
Yep.
When you do Conda deactivate, does it just deactivate like the environment you're in? Or
Mhm.
like can you have multiple environments like activated? Or
No.
So you would just deactivate the one that you're working on?
Yes.
So last time you actually deactivated Conda, it didn't show the path. So the command didn't show up, but then now when you deactivate it, it still shows on in the path, but then you do get it.
So we're talking about the path. So this conda bin is active because I ran that source command. Now, that does not mean that any environment is active. So just because I have the Conda bin does not mean that I have any of the environments active. So what I was showing you with the path, right, is that this is currently active. And if we were to Conda deactivate, I think there's another example of that up here. So if I Conda deactivate, I lose just this bin, but I'm not going to lose the Conda command itself. Does that make sense? So Conda deactivate will activate or deactivate an environment, right? But the Conda bin, so having the Conda command itself, that's managed with that source command, which I only have to run once at the beginning of my session. Or if we're in a job script, it has to be at the top of the job script. And then you can activate and deactivate environments on the fly.
So is it mean that second, the on the bin is related to the base, and then the base is always there, but the extra environments that switch in and out?
Yes. So the base is going to be there, right? So when we source it, we get the Conda bin. But I don't think you actually get the Conda base activated, because I think you can still Conda activate base. So the base environment is another environment. It's just a different one, right? So I do not think you can. If you can, I would not recommend it, because you're probably going to confuse yourself. So I would activate an environment, use the tools in it, deactivate, activate a different environment, use the tools in it, deactivate. So there's lots of comments in the chat. Anything? No, it's just Oriole chatting. Anything worth sharing with the larger group?
No, it's just about why do you use source and not go inside the Conda environment and just, to buy Conda environment? And the answer would be, while you have complete control when you install Conda locally, in some machines Conda will be installed by the admin or somewhere that you cannot access, and there will be like a Conda executable under a user local bin or something where normal users can execute it. So usually you just do a source for that and it will load everything.
Yeah. So I prefer to maintain control of my own Conda, just because, well, so if you maintain control of your own Conda, then you can run environment creations like this, and they're going to go to a place that you know. If you use the Conda that's in the LMOD system and you try to run this command, it'll throw you an error saying you can't write to the default space. Now, you could set a separate directory, but just for the sake of beginner Conda, this is the way I prefer to do it. Okay, moving on. Again, if we wanted to type which Conda, that's the Conda that we're in. Okay, so coming back to our directory, we have this directory now. A separate way to make environments that's more reproducible is via the YAML file or a YAML file. And we can take a look at this YAML file that we have if we cat genomeanalysis.yml. Now, this is a very, very basic YML file. And what you need is you need the name of the environment. So we're going to call this genome analysis, which would be the same as our previous example where we called it tree, right? We're just setting that environment name. The channels that we need, I know that all these tools are in the Bioconda channel, so I'll just add the channel Bioconda. The dependencies, so here I'm going to list the tools that I need. So I want BWA, I want SAM tools, I want HTSlib, and I want Picard. And then I'm going to give the prefix. So this, again, is just an explicit showing that I want it to be installed into project, STS Turvy 1, Precision Health Virtual Environment, Software, Mini Conda 3, ENVS, Genome Analysis. Now, you may realize that you do not actually have permission to create an environment in this space. So what we need to do is we need to modify this YML file, and we are going to do that with nano. So we can type nano genome analysis.yml. And the first thing we're going to modify is that we need to set some version numbers. So if we leave these without any versions, there are probably 100 versions of SAM tools, probably 10 main versions of BWA, dozens, hundreds of versions of Picard, and hundreds of versions of HDSLib. So because there are so many different versions of these software packages, it's always best to be explicit in your files of which ones you want to use. And then we're also going to modify the prefix so that we change this to be a path that we have a space to write in. So for me, I'm going to put this now into this directory we're currently working in, which is Scratch, TR Precision Health 1, workshops, student spaces. Put your own username. I'm putting mine here. Core Conda, Mini Conda 3, ENVS, Genome Analysis. So I can go ahead and make these changes. BWA, I think I said what, 0.7.3, SAM tools 1.15, HDSLib 1.15, and Picard, I don't know, 2 point something, 2.27.0. Then I'm going to go ahead and change this. /Scratch. Again, this could be STS Turvy 1 or TR Precision Health 1. And then I'm in workshops, student spaces, my own username, Mini Conda 3, ENVS. So it's always good to make sure that this actually exists. And we are going to Control O, enter, Control X. Make sure that that exists. No, it does not. I made an error. Workshops, student spaces. I must have missed something. It's always learning. Core Conda. So now let's make sure that I've got this directory. Control O, enter, Control X. I do. All right. So now that I've got this set up, the next thing I can do is I can run conda env create -f for the file genomeanalysis.yml. So conda env create -f, and I've got this genomeanalysis.yml. This one is going to be a little bit heavier to install than tree. There are some big dependencies in C for SAM tools and HDSLib. So instead of our small list of dependencies and a quick solve, it's going to be a little bit longer. Any questions while we wait for Conda to solve? Questions from the Zoom? Maybe I should have picked a smaller package. So when this package finishes solving, it's going to be, we'll be able to activate it just with Conda activate genome analysis. Oh, it finished the metadata. Now it is solving the environment. And then it's going to run. There it goes. So thinking about one of the reasons why we use a package like Conda. So if you've ever been faced with a tool that you need to compile, it may say that you need libraries that are missing, like libblas or ncurses or glib or make or libdeflate. That's probably one of the nastiest packages to try and install. So instead, with Conda, we let it handle those challenges for us. It downloads those that it needs with specific versions. You can see every one of these has a version. And then it's going to create those tools to work on our computing platform. So right now we're on Sockeye, but tomorrow we might need to work on a Digital Research Alliance of Canada platform, or we might work on the cloud in something like AWS. Conda will work in all those different environments. So as long as you come back to following this same set of instructions for deploying your mini Conda, right? Those 4 steps here to deploy, and then creating environments, you'll be able to work on any platform and get access to these key tools that you may need. Got to be getting close. You can see there are several things that are being downloaded and extracted.
Hey, Phil, we do have a question in the chat regarding found conflicts, looking for incompatible packages while solving the environment. So what do we do when that happens?
Yes. So if you have an issue with conflicts and looking for incompatible packages, that's probably the result of you trying to shove too many different packages into an environment. So I would say the first step would be to back up and to try and install the tools that you need into their own unique environments. So a given tool will only ever have one set of dependencies and one set of versions with dependencies. But as soon as you add another tool, and if you add 20 tools, then you're going to having this issue following the steps on the slides. On which?
The incompatible.
Did you make these modifications? Where does it show you that you have the? Okay, so some of you may have not changed Richmond P to be. Okay, well, mine worked just fine.
Okay, I guess what do you do if you installed it in the wrong path? Do I have to uninstall it first with genome analysis and then you install it in the right place?
So if you found conflicts, one of the things you can do is you can try to simplify. Also, if you found conflicts, you might not have typed these exactly as they are here. So for example, if you put 1.16 and 1.15, then you're going to have an issue. If you have conflicts with this genome analysis, then you can just activate the environment that I made for subsequent tools. We'll try and figure out what's going on with those conflicts after the session's over. Did anyone get it to work?
I changed my music.
Okay. Well, we're going to continue on with the slides. It works for me, so we can figure out later what an issue is. So someone got it to work. We are doing installation in the base environment, right? No, never. No. So if you are installing into the base environment, that's where you're going to have conflicts.
Yeah, that's good.
If you have already tried to install Conda yourself and you have something like Conda activate base, something silly like this, then you will have conflicts. This is why we use mini Conda. So if you have something like this, then you need to Conda deactivate. All right. So if you've already tried to go through Conda yourself and you maybe did the big Anaconda and you've got some beastly base environment, when you try to install packages like libdeflate or any of these packages that are so clean in miniconda, that you will run into problems. So always make sure there's no base environment active, and always make sure that you're using miniconda, not Conda. So we will try and solve some of those issues that people have, but this is exactly the reason why we don't do Conda and why we don't mess with the base environment. Because what's likely happened is that in your base environment, you've got one of these libraries installed with a specific version. Maybe libcurl is often the one that gives a problem. And if there's a conflict between your base and the libcurl that's needed for the tools we requested, then you will have an error. So always miniconda. And if you have something like this every time you log in, that's probably because in your .bash profile or in your .bash RC, you're going to have some junk about a conda, right? If you see that, we'll help you delete it. We're going to do that after we finish this session. So, good learning experience for us. The last thing we're going to do here is we are going to export the environment. So we are going to run conda env export on our genome analysis environment. And what this is going to do is it's going to give us a much more detailed output YML that is specific to all of the tools we have in that genome analysis package. So I can type this, conda env export -n genome analysis -f. I want to put it out into this exported genome analysis.yml. Now, what this is going to do is I've now got a brand new file called exported genome analysis.yml. And this is something that I could share with collaborators, or I could move from system to system and have the exact same environment. So if we look at our genome analysis YML, I only listed 4 dependencies. But if we look at our exported conda environment.yml,
It's complaining about the GLib library, which tells you about the content.
which for what?
So he's trying to follow your instructions
Uh-huh.
on the software, and he gets a complaint of the GLib library is not compatible with the PWA samples, HTML1 library.
Did he? Maybe Jerry can help. All right, debugging conda environments is something I've spent a lot of my time doing. So we are going to wrap up conda here. We'll take just a couple minutes to discuss a few things, and then we'll get into Singularity. The last thing is that when we are working within our bash scripts, all we need to do is add this at the top of the script, and then we will be able to use those tools as we need them. So if you did not deactivate your environments when you go to create a new environment, you might have a conflict between what's currently in your path and what you're trying to install. And that could be where you're finding these conflicts. So if you were going through this operation and you got conflict issues, try to Conda deactivate and then rerun them. If we have multiple different Conda environments, for example, if this was our job script, we first run the source of our Conda to get the Conda tool in our path. Then we can Conda activate the name of our environment, use the tools in that environment. And because we don't want these environments to get too large, we can then Conda deactivate that one and Conda activate something else, a different environment. For example, one with tools for structural variant calling, like Manta and Cienbinator, popular versions of tools. So also remember, if you put too many tools in one environment, it will take forever to solve. So make smaller environments, activate them within your script when you need them. If you want to play around, you can go ahead and work with this, make an environment with the tool of your choosing, activate that environment, test your tool, test your environment in a job script. All right, let's take a quick stretch and then we will get into Singularity.
I'm trying to get the genome analysis part to work.
Mhm.
And it looks like I can install it. And then when I try to run it, it says I can't find the command.
Can't find what command?
The genome analysis command. Like,
They can
like, want to activate genome
yeah,
analysis.
so they probably failed to install genome analysis.
Yeah.
Oh,
If you look that up, it'll say like conflicts for.
oh, yeah,
And it's
found
probably
conflict,
the
right?
GLibC library, right? It says GLibC +17.
Oh, at the end. Yeah, found one. There's a whole bunch of conflicts.
Yeah.
At the very end, it says your install version is 2.17.
Yeah. 117, so it's the GLibC. What I do usually when it complains about this, I start removing versions of the packages that I'm trying to install.
Because I know which version I installed.
Yeah, so you're trying to install. So it's complaining about.
Okay, so
UA, right? So what I will do is here remove the version because you are forcing 0.73, and that has been compiled with whatever version of GLib libraries.
Oh, okay.
And it's incompatible with whatever version of GLib library you're using.
all right, so if you've got issues installing tools, this is something that you may run into with Conda. All right, let's bring it all back in. Let's solve these Conda issues after the session. We can try. Okay. And there's like 60 people online, so we're just gonna continue moving forward. All right, so containers. There's still a lot of chatter happening, so we'll try and just give people another minute, and then we'll get into containers. We can all look at pictures of Sherlock while we wait. All right.
It's installed.
Well, yeah,
Delete all four.
give me, no, give me a
Oh,
second.
sorry. I'm gonna figure out.
The only thing is counting, I think I would do 0.717.
Right.
And, yeah, we'll see which one is selected.
So some ways around the issues that people are experiencing is to add or is to remove the specific versions here. Let Conda solve that will figure out something that works for everything. And then if you do that, when you export, you will still be able to reproduce everything with every package version that you used. Okay, let's go ahead and move forward. So if you have Conda issues, you're not alone. And the problem is that even with Conda, we will have challenges with certain libraries and certain versions of tools.
Also, what I do too is if I want to use a specific version and the Conda installer is complaining, I will download the package and install the package myself. Like you can do Conda install and a package that you download from that website. So from that website, when you visualize the packages, there is a downloadable version. So you can download the package and install it yourself.
Okay. So what Oriel was talking about is that on the Conda, if we actually look at the packages here under files, you can download these packages and run a Conda install directly on, you just reference the zipped package?
Yes.
Yeah, that's something I haven't done, but we're going to go ahead and move on. So the reason why Conda sometimes fails is that the recipe may be incomplete or there may be dependencies that are challenging. Now, that's where containers come in. So the problem, again, bioinformatics software emerges rapidly. We have this complex system of dependencies, and sometimes there's conflicts, which we've just experienced today. Also, analysis pipelines are often complex and may rely on many different tools for different stages of a pipeline. And lastly, we need reproducibility of our analysis. So we need a consistency of software behavior and portability across different computing platforms, which is where containers come in. So the idea of a container is that you can think of it just like this little cube, where there are really three things you need to think about. One is going to be an operating system. So some people will put an entire version of a Linux operating system or the Mac OS or even Windows. Next, there are going to be the software compilers, dependencies, and libraries. So glib being one that threw some errors for us just now. And then lastly, the tools that we want to use. So containers can be created with incredible flexibility. Now, container creation is not something we're going to cover today due to time, but there are some workshops that have been hosted previously by ARC where you can see how to create your own Singularity container. Now, if you ever see instructions in an install of a package, for example, from GitHub, where it says something like run sudo apt-get followed by the name of a tool, you know that you do not have the sudo command privileges on a system like Sockeye. So you can't run those commands. The most popular container for bioinformatics, and I think right now in general, is called Docker. But for shared systems like Sockeye, Docker has permissions challenges. And to confront those challenges, the Singularity tool was born. So the containers that we use can be stored and shared in the cloud. So there's Docker Hub. I also recently found out that GitHub has its own container repository. So these containers are hosted on the cloud we simply pull them down from the cloud to whatever platform we're working with, whether that's Sockeye. I guess this is now Digital Research of Alliance of Canada, or even a cloud platform. So we're going to pull the container down onto Sockeye. So today's focus, what we're going to do in the next 50 minutes is we're going to find a container for our own purpose. Here showing an example for the deep variant tool. We're going to pull the container to Sockeye. We're going to briefly explore the container, and then we're going to run the tools inside the container through a Sockeye job. Again, we will not cover how to build a container. And if you go to the ARC website for training, you will be able to see there are some Singularity slides and workshops available there. So the tool that we're going to use is called Deep Variant. And I think for the sake of time, I won't spend too much time on this, but this is a popular variant calling tool made by the Google Brain team. And it's going to input, if you remember from our last class, the alignment file or that BAM file. And it's going to take a reference FASTA or that reference genome that we also explored in our last class. And it's going to output variant calls in the VCF or in the GVCF format. So first, let's find our tool. So how do you find a tool? Well, we can go to Google, as we do. We can type Docker Hub. Google. We can type Docker Hub Deep Variant. And we can see our first option at the top is this Google/Deep Variant package on Docker Hub. Oh.
Yeah, sorry, so maybe we need to ask them to think of the environment.
Right. Okay. So Jerry has just notified me that with all of you lovely people following along, we have reached the file limit for packages on Scratch. Can we ping Roman and tell him to bump it? Okay. Okay. Okay.
Yeah, I should remind you of the, I should say that earlier. It's better to create the Conda environment in projects because they have lots of small files.
Yeah. Okay. Okay. Thank you, Jerry. Okay, so we are going to quickly. So what Jerry had just notified us is that the everyone creating packages in this core Conda directory on the Scratch space has reached our file limit. So if you can go ahead and run rm-rf on your, we'll just delete that mini Conda 3 environment. This is us learning as we go. So if you type that command, then we will be able to proceed with the second half of the workshop. So run that for now, and I will go back to the slides. So as Jerry mentioned, just back on that Conda issue, yes, it's best to install tools into the project space. However, for the purposes of this workshop, we are just in the learning stages, which is why we use the Scratch space. So if you're setting this up in your own allocation, I do recommend putting these environments into the project space as opposed to the Scratch space. So hopefully we can clean up some of those files. Hopefully people can run this command. I will go ahead and pass. Actually, I guess we can even just say, let's go to the Slack. Yeah.
I don't know how quickly you can.
Yeah, just send him an email. He might do it real quick. So, okay. Awesome. So coming back to Docker and Singularity. So we found our Docker image that we want to use, Google Deep Variant, and we found the command that we're going to want to run. We can also see on this package that there are instructions for how to run Deep Variant. At this link, we can learn more about the Deep Variant GitHub tool. We can see there's a version of it called Deep Trio, and there's lots of documentation here, which if you're a first-time user of the tool, I recommend you visit. We can also follow the quick start. So this Deep Variant quick start shows you how to essentially run a test set with their command. Now, as we saw before, we do not have permission to run this Docker command because we do not have sudo privileges on Sockeye. So instead, if we keep scrolling down, we see that they were nice enough to make a Singularity version of the same command. And you'll note they still operate on the same exact Docker container. So for the vast majority of use cases, the Singularity pull command will be able to work with native Docker images. So again, how to run Singularity version, we can follow those instructions there. But we can go ahead and start by setting up our space. So that is going to take a little while to clean up. I'm going to go ahead and make a new terminal. All righty. Okay, I didn't even need to. All right, so we have we're in this space, Scratch, TR Precision Health 1, Workshop Student Spaces, followed by your username. And we are going to CP-R, this core Singularity from project space into our current directory. And then we will change into that core Singularity directory. Next, we're going to load the Singularity module. So I'm going to type module load Singularity. There are many versions of Singularity on Sockeye. The most recent version for our work here should be fine. If it doesn't work, you can explore the other versions. The next thing we're going to do is we're going to run the Singularity pull command. Now, it's best practice to pull a specific image with a specific version. We can find the options under the Docker Hub page under tags. So if we come back here, this is just going to pull the latest version. Instead, we can pull a specific version. Here we want version 1.4.0, and we can see the pull command would be docker pull Google/deep variant : 1.4.0. So if we come back to our slides, we can run, instead of docker pull, we're going to run Singularity pull. And what we need to do is we just need to add this docker : / in front of what the docker command would have been. So here they say docker pull Google Deep Variant 1.4.0. We will instead Singularity pull docker : / Google Deep Variant : 1.4.0. We can run that command. And what it's going to do is it's going to pull onto our current working directory and create a SIF, Singularity Image Format file. So it's still running there. And when it's finished, we will have our deep variant .sif file. So again, what we did is we went into our workshop directory. We copied the core Singularity directory. And then we changed into that core Singularity directory. We ran module load Singularity to get the Singularity command in our path. And then we ran Singularity pull on this Docker image.
Once they pull the SRS file into the current directory. So since we are in the core Singularity, so it's stored in this folder, but if we go other directory to pull the SRS down to the current working.
Yeah.
Okay.
Yeah, you can specify a path for it to pull to. This is a big image. All right, it's almost finished. And when it does finish, we will have a deep variant underscore 1.4.0.sif. Now, the nice thing about these image files is that once you download it, you could move it to a different place on the system, and you could always just point to that specific SIF file. So if you have, and which is why it's also recommended to do this on the project space as opposed to the Scratch space. But again, for the sake of this workshop, we're just showing you the commands and how to set up this space. But in practice, you would be doing this on your own allocation under the project mount. All right. Still thinking. So that's what.
Somebody was asking about whether you source Singularity instead of.
No. So Singularity is a tool that needs to be installed on the head node and on the compute nodes. And the Singularity installation is not as simple as just sourcing that mini Conda, right? So you couldn't install Singularity yourself to run on Sockeye. Instead, we use it from the module system since it's been installed by the administrators. Okay, I don't know why it's taking so long. Let's go ahead and So just for the sake of showing you how to interact with the Singularity images, I have a Singularity image installed here. I think I also have one installed here. So you can see on the project space, I've got Singularity images already installed. And so the best practice would be to create a directory with deep variant to show how I got the deep variant Singularity image. So for example, what was the poll command that I ran. Wow, that's a lot. What is the command that I ran? And then to have that in a directory on the project space. So for now, what we can do, just for the sake of our, in fact, it's already 10:25. So we can run Singularity shell. So once this finishes, we'll be able to run this on the deep variant tool. Singularity shell. We'll just follow along on the slides. So what this is going to do is it's going to show you that it's converting the CIF file to a sandbox. And then it's going to create a new looking command line where now the command line is actually going to be inside of the container. And so if we run an ls from the command line inside the container, it's still going to show us the files that are in this core Singularity directory. So by default, our container will be able to see the contents of the directory that it sits in. So if we type something like ls, we can see the files that are in our current directory. However, we can also see that the deep variant tool is going to be in a path according to this how to run deep variant command here. We can see that it's in a path /opt/deep variant /bin/run deep variant. Now this is a path that is inside the container. It is not a path that is on sockeye. So if we come back to the slides, we can see that if we were in that container and we run ls/opt, that it's going to show you the deep variant subdirectory. Whereas if I was to do ls/opt on sockeye, there is no deep variant directory. So again, this is the concept that the container is going to have a different root directory, a different first/opt directory than we have by default on sockeye. So in that container, we could also run ls/opt/deep variant/bin. And then we could see in the bin this run deep variant command, which is exactly as it would be as we call that command /opt/deep variant/bin/run deep variant. Now, an important thing to mention is that if we needed a file or we needed access, for example, to a reference genome or a database on the project mount, and we were to try and list out the path to that project mount, it would tell us that there is no such file or directory. That's because, again, the Singularity image can only see the things that are inside the container and the places and the directories and files inside the container path. So if the container is in /scratch/tr precision health 1/workshops student spaces Richmond P core Singularity, it'll be able to see the files inside that path, but it won't be able to see the files elsewhere, like on the project space. Now, what if we need to access files elsewhere? Well, we do that with the bind command. So with the bind command, we are exposing the file paths on our host system. For example, the /scratch or /project, or even outside the directory of the image with binds. So when we run our Singularity exec or our Singularity run command, we pass a bind, and then we can point to some path on the system, and then we can call our CIF file. So even though our container is sitting in this space, we'll be able to access this other space with the bind command or bind parameter in the Singularity command.
adding multiple places, because sometimes some project may have the data in TV folder.
Exactly. So the question is, can you bind multiple places? And the answer is yes. As you can see, we've got this. We can take a look at our scripts directory. I think we may have just beaten the file system, and it is not happy with us. Is anyone able to get their CIF file or? Oh, okay. Now it's unpacking. We have progress. I thought it might have died. Okay, so, back to the slides.
Sorry.
Yep.
So for binding, it's like when you're inside looking, trying to look out of the container. If you're outside of it and you want to get something inside, is it, if it's already in like a folder within your thing, you can just look it without binding?
If you're,
Did I explain that?
mm,
So core singularity is a container that's installed like a folder inside your user folder, right?
yeah, so core singular. So this is a path on the sockeye.
Right, so then when you're in sockeye and you want something that's inside the core singularity container. You just.
Oh, you mean inside the devariant container?
Sorry, the variant container, can you just, when you're in sockeye, just give the full path?
No. No.
So when you want to access something inside the container, do you also have to find it on the outside?
If you want to access something inside the container, then you need to run either Singularity exec or Singularity shell. So you need to enter into the container in order to see what's inside of it. And typically inside the container, it's only going to be like the tools that you need to run a job. So you wouldn't package like data in a container. The data would be on your file system, like on Sockeye, and we would bind the data. And so you'll see, I think the best is for us just to see an applied example. So this is still having a lovely time finishing. We are going to go ahead and just take a look at a script. So if I've got another window open here, we can just go ahead and go to this directory. We can go into, what do I have? Oh, yeah. So we can take a look at this command. So this is a script called deep variant _ proband. So in this script, what we have, we can just walk through it. It's probably cleaner here. So at the top, again, this is a job script. So we've got the resources that we need at the top here. If you've never seen this before, this is something we covered in the session yesterday afternoon. Now we have at the top some setup. So here I'm setting my working directory, which is where we are. I'm loading the Singularity module. I'm pointing to the .sif file, which we're in the process of trying to pull. And then I'm giving some labels for my sample is going to be the proband. The BAM file is going to be proband.sorted.bam. And the BAM directory is going to be the working directory / files. So if I list out the files directory, you can see I have this proband.sorted.bam. That's going to be essentially this file here. Is there a question? Nope. Okay. Now, yep.
Singularity has Singularity shell and a Singularity executive seems both go into the container.
Mhm.
The difference between the shell and the executive.
So the shell is going to move your command line into the container, and then you'll be able to interact in the container. So think of shell like Q_I interactive. You're going in, your command line changes. Singularity exec is more like, let's run a tool that's in the container. Yeah. So what we can do now, this is just still going. All right. So we can now take a look. There was a question about binds. So could you bind more than one path? Absolutely. Highly recommended. So here you can see I've got 5 different binds. And there's 2 ways to go about binds. Now, this is how they describe it on the deep variant page, right? That they bind into, oh, they actually changed it. So previous versions of this doc would show you that you had to create a bind between some path on your system and some path in the container, right? So what this is doing is it's creating a new path called in the root directory of your container called bamdir. It's creating a new path inside your container in the root directory called genomedir. The problem is then when you refer to files in that directory, you have to give the new relative path in the container. And that can just be flat out confusing. So instead, what we can do is we can just bind those paths without giving them some new location in the container. And what this will allow us to do is just to refer to those paths as if they were on the sockeye system in their original format. So when we run the bind command without passing this colon into some new container path, now the container just has access to those directories, which if we look back, it will just be able to see this working directory. It will just be able to see this directory for our genome, which is here on the project space. Breaking down the rest of this deep variant command, we have essentially Singularity run. We pass our binds. We then pass the CIF file. Then we call the actual tool inside of the package, which we know is in the /opt/deep variant /bin/run deep variant. That's the relative path inside the container. And then we pass the rest of the parameters for the call. Here I'm setting the model type to be whole genome sequencing. The reference, I'm pointing to my FASTA file. The reads, I'm pointing to my BAM file. I want to output, and again, here I'm outputting to some TMP directory, and the number of shards, that's just the number of CPUs, which is what happened to that? Don't do that. Which has, this is essentially an environmental variable from the PBS job script. So again, comparing the 2 different ways of binding, I would always go with this manner of binding, where we just bind the directory full stop, and now it has access to those spaces. You can also see that I'm binding the temporary directory, which we learned about yesterday. This is an onboard disk that's on the compute node itself. Any questions about this Singularity command? Cool. All right. So we can, this is not going to work for you because your container, if your container is finished, you can run this command. If your container is not finished, this will not work. Based on the time, we will not fight with this. If you can run this, go ahead. Essentially q sub scripts deep variant _proband.sh. And if our container ever finished pulling, then we would be able to look at this output, and the output that we're going to get is going to be essentially variant calls for this sample input BAM file. So some common issues with Singularity. You might forget to bind a path, and having the container command not be able to access a specific file. Oh, it's happening. If you get conflicts with your base environment and the Singularity environment, you can try adding this --clean env, which this will do is that if you have, for example, a version of Python in your path, this will remove all those environmental variables, and you will only have access to what's in the container. So just like we had conflicts with Conda between something that we've already got active and some tool that we're trying to use, you can have the same issue in Singularity. And this clean environment will say, just focus on what's in the container, ignore the rest of the sockeye system. And lastly, if you're pulling something from Docker, just put Docker : / in front of the requested Docker pull command. An example of this was for this workshop when I had to put together, if you end up going through the problem set, the GL Nexus tool. GL Nexus is not on Docker Hub. Instead, they give you a Docker image with some address, this being a GitHub CR. I think this is GitHub crates. So this is not Docker. So I fought with this. I said, how do I pull an image from ghcr.io? Well, the answer is simply put Docker in front of it, and then Singularity pull from Docker : that path, and it ends up working. All right, so that is it for the morning session. As soon as your SIF file finishes, you can then try to explore it with the Singularity shell command, and you can also submit this job, scripts deep variant proband.sh. And lastly, if you want to have even a little more than that, you can work on the Singularity problem set, and that Singularity problem set is going to request that you run this job, which will run essentially deep variant on that same CIF file for your proband, for the mother, and for the father, and then it will run GL Nexus to joint genotype those and produce a family merge.vcf.gz. So if you ever do any trio-based rare disease genome analysis, this is a nice pipeline to go from BAM files into a joint genotyped variant file. And other than that, I guess we learned about pulling big CIF files during the session. So in the future, again, you can run these pulls separately. And for example, in the precision health virtual environment in software, many of the future workshops that you're going to get into, for example, when we use Nextflow, when you were using fMRI prep in the fMRI analysis workshop, we will have these SIF files already downloaded for you. Even the GLS Nexus or GL Nexus file is also already downloaded. So what I will do is I will also, just for those of you who maybe couldn't get this job to, or this pull command to finish, we can also put the SIF file for deep variant into some directory here for your use. All right, and with that, that is the end of the content for the morning session. So just to come back to what we covered all the way at the very beginning, we motivated software environments. We experienced Conda, including a simple install, as well as conflicts that can emerge when you try to create environments, especially those with your base environment. We then did an intro to Singularity where we attempted to pull a container, which will eventually finish, interact with that container, and then run the tool inside the container within a job script. So if you have any questions about this, please feel free to discuss in the next 15 minutes. I will go ahead and stop sharing my slides. And yeah, thanks everybody. Yeah, so ARC has increased the file limit. I think many of us deleting at the same time. That's probably why this Singularity pull command is having trouble. A lot of people doing the same thing on the same part of a file system can cause it to struggle. So. Go ahead and kill this recording. And yeah, see you guys in the afternoon session.